All right, welcome everybody back to the channel. Luke here, and again with Ghost. And today we've got a very special interview with some of the Constellation team. Thank you for joining us, guys.
Thank you for having us.
Yeah, pleasure to be here.
For those of you who don't know, how about you guys just do a quick intro on who you are?
Wyatt, you want to jump in there?
Yeah, sure, totally. I'm Wyatt. I'm a co-founder and the CTO of Constellation. Pretty much nuts and bolts programmer type. I'm here to talk about the tech thing, and yeah, you'll learn a lot more about me, and I'm sure anecdotes about my past in this meeting or interview. So, thanks.
I'm Ben Jorgensen. I'm also one of the co-founders of Constellation, kind of responsible for overarching strategy and serve as the CEO of Constellation Network.
Perfect.
Awesome to hear from you guys.
All right, so so to get started, we're just going to kind of do an overview of what Quant's been up to and what they're building, and then we're going to kind of dive into Constellation and what you guys are building and how the two can work together to bring additional value. So for most people watching, they probably already understand Quant's value proposition, but they're building an easy plug-and-play solution for enterprises that allows them to, the way Ben put it earlier, like a track switch, so they can go down different paths, different blockchains, different currencies, and interoperate between them. Obviously, this is very important in the current blockchain space, as a lot of networks and ecosystems are operating in a siloed nature, and to really bring them all together, they need to have a way to communicate and operate as kind of like one seamless network. And so maybe if you guys could just give a quick brief intro on Constellation, and then we can dive in how the two could work together.
Great. Thank you. Yeah, I think that's great to kind of frame how Quant fits in this ecosystem. And then why is Constellation talking here? Well, Constellation is a network. We call it the hypergraph network that Wyatt has built. That is a resilient, decentralized network that's globally distributed. And it's really built to cryptographically secure complex data types. So really, this is the first cybersecurity solution for big data processing. So you could think of Constellation as a plugin to a Kafka data pipeline, or working in stride with a data pipeline while adding cryptographic security. To date, Constellation was really focused on establishing our main network, which we have about 25 to 30 nodes that are globally distributed, that are earning validator rewards across our network, and are really there to uphold the state of the network. And what we've done today is built DAG, our cryptocurrency. And really how we think about this in conjunction to our long-term vision is that DAG is really there. We're cryptographically securing a simple data set. A transaction is hashed on our network. We're cryptographically securing ledger balances. And that's very simple. Well, that puts us on par with all the other networks that exist out there. And what Wyatt and his team are building are a way to add data points or complex data types and more data onto that transaction and secure that on a network using concurrent consensuses.
Perfect. That's a nice overview right there. Wyatt, would you have anything else to add?
I mean, I think that's definitely self-contained. I think if I just were to drive it home, maybe I guess I'll do the higher level. I mean, we are, I'd probably just say the first leaderless auth tool. And we scale in such a way that, we natively fit into the same type of backend that any engineer would be building, at a, B2C type tech company.
Awesome.
Yeah.
I think
we're seeing, go ahead.
Oh, no, go for it.
Well, I was just about to say that we're seeing a whole generation of attempts at this type of architecture. But I think Constellation is the most generally applicable one that I've come across, just due to its robust mathematical approach. But go ahead, Ben. What were you saying?
No, I mean, I'll say that I think the U.S. Air Force has, and the federal government has a lot of the same sentiment as they're looking for alternative networks to securely transport data. And really, one of the fascinating things in data is that we're all kind of learning what our data strategy is. All companies, down to the Air Force, and we have talks with them weekly on identifying their big data strategy. What tools are we going to use? What data management solutions are we going to use? What standard are we going to use for a data schema when data is coming off of this device? And we're seeing the same thing in the mobility sector as well. And so when I look at Quant and our compatibility, because there are a lot of overlapping aspects to this, is that Quant, like we were defining earlier, is that switch. Primarily Quant has worked in the financial institutions in establishing that switch to be able to swap between different currencies seamlessly. It should be that easy. You shouldn't have to go through giant exchanges. And so that piece of technology is really kind of a railroad operator selecting which railroad to go down. And so when you start to think of Constellation and why we're even in the same room talking, Constellation and really why its mind and engineering team have come up with are a low-level technology that are recreating the roads or the rails by which data is transacted. Mm-hmm. And so cryptocurrency, and what Quant has done, is created the ability to switch between different railroads in the financial institutions, those financial currencies. Well, data is that next step into creating roads by which data can seamlessly be transferred between different devices, machines, and people. And Quant can play a huge role in being that operator switch that allows machines to easily. Yes, between different ledgers, also between different systems as well. Yep.
That's
so yeah.
Awesome.
So in a simple way, Constellation's like the new railroads by which of transacting data, and that's kind of evolving cryptocurrency and simple data structures to complex data types that we see collecting data from sensors and our phones and our personal data and healthcare data and all these things that are spitting off data and are going into AI and machine learning algorithms. That's where our mind is. Currency is one thing. Data is the currency of the future.
Absolutely.
Awesome.
So go ahead, Luke.
I was just going to say that was fantastic. Thank you. When you guys started working with Quant, you guys mentioned smart cities, and could you maybe just elaborate on how your work with big data and as you said, building those rails for the data to be authenticated, and etc., how that could help in the smart city example and how that would work with Quant, perhaps?
Sure. Do you want me to jump in there, Wyatt, or do you want to go for it?
Just one sentence and I'll let you take it. I mean, really, it's all just data under the hood, man. I mean, whether or not you're sending a transaction or you're sending, a video, it's, you need to be able to secure the API, the data creator, and metadata on it.
Awesome.
Bingo.
And to Wyatt's point, complex data types are images, they're videos, there's a lot behind that. And what other ledgers have done to date are really kind of the management of the asset as it moves from A to B to C. Managing from A to B to C, and now the way that we look at it is like, that's great that you manage the asset as it moved, but what happened to that asset? Who had access to it? What are the features of that asset as it moved from A to B to C? And so this opens up a whole new world that Constellation's defining or productizing is programmatic compliance. So when you look at a smart city, in order to be a smart building or a smart car that's connected in a smart city, you have to think about how are they communicating with each other? What's the standard by which they communicate? And what is that standard or protocol by which they communicate? And that's what Constellation's building, is that communication standard. And for a product, for a smart building to incorporate us, we call that programmatic compliance. They're showing they're compliant to the rules of how data is exchanged within a confine of a secure smart city or something like that.
And that actually goes really nicely into recent activity of your team, Benjamin Diggles in particular, on a paper he co-authored with Moby and it's Schaeffler. Is that how you pronounce it? Schaeffler?
Yeah, Schaeffler.
Yeah. So they're as far as I recall, they're the largest OEM manufacturer in the world.
They're one of the big major automotive suppliers.
Yeah, they're at least top 3. They're big players in automotive supplies and supply chains, and so they wrote a paper recently on why B2B data transfers don't work. Isn't that the focus?
Yes. Basically articulating the need for a data marketplace or exchange for autonomous vehicles to exist.
Yeah, and one that is autonomous in and of itself.
Yeah, that is correct. A shared economy of sorts. Yep.
Yeah. Well, and Benjamin has really great experience mediating these B2B transactions. I mean, that's where he comes from before, right? His history.
Yeah, funny enough, I met Benjamin when I was building my last startup. We did an integration with Oracle, and Benjamin was the he was overseeing business development for developers in the Oracle Cloud Marketplace. Mm-hmm. And we ended up becoming really good friends. I think we were one of the first guinea pigs on doing that integration, which was oddly extremely basic. And so we became really good friends in that whole process. And he is one of the most exceptional individuals on business development that I've ever come across. And it takes a certain finesse to work with the United States military. There's a certain language and cadence and professionalism that he exemplifies.
Yeah, absolutely. He as far as I can tell, he's a whirling dervish of biz dev pipeline. So he just keeps bringing in all these different contacts. It's amazing to watch. Yeah,
absolutely.
So I was just wondering, on that collaboration, how do you, and being a standard of data exchange, how is Constellation viewing itself as a fundamental, what would you say, tool, I guess, for automated data exchange? Are you guys taking that to market as a product together? Is that something you're interested in, at least?
Going to market with Schaeffler on something?
Oh yeah, or Moby, or whoever in the consortium could use Constellation. I mean,
Yeah, so I think one of the things that we saw in early trends in the mobility sector was they were quick to pilot blockchain use cases, but had no way of deploying it into live environments or plugging in with existing data management solutions or any sort of meaningful way to capture data. So while they're really fun test pilots, it didn't surmount to anything meaningful. And I'll let Wyatt go into more of why that is. But that's where Wyatt's idea of if you're going to make blockchain procurable, not only just or easy to adopt, it has to not just be the technology itself, but how you articulate it and how easy it is to plug in with existing systems. Mm-hmm. And that's where blockchain really hasn't tackled that at all. Mm-hmm. But even going a step to where we are today and working with Moby, Benjamin's been spearheading a working group with GM and Denso and several others in that group, where they're going back and saying, hey, we did it wrong. We piloted these things too fast. There's a lot of value there, but this whole data piece is actually the missing link. So now we feel like the whole industry is starting to catch up with what we've been building.
Shifting. Slowly.
Yeah, shifting it. And now they're defining.
Yeah.
They're like, okay, what data do we want to collect? And what does that schema look like? And now what are the rails by which we can capture and secure this so that we can prevent spoofing, prevent threat vectors?
So what did you call that? Was it a compliance, but it's algorithmic compliance?
Would you call it programmatic compliance?
Programmatic compliance. There's a similar term for, in financial terms at least, from the BIS, from Raphael Auer, that he calls regulatory automata. So this is automatic regulatory compliance, and it's basically a node that is centrally managed for the sole purpose not of clearing ledgers, but making sure that the rules by which are being followed. And the data by which, I mean, you could even generalize this further as a GDPR compliance node to make sure that there's no PII data being transferred among different DLTs or what have you. I mean, that right there is an amazing use case that of programmatic compliance, as you guys are trying to build out. Yeah.
Yeah, absolutely.
That's so cool. Yeah. So, do you guys want to talk about perhaps how's mainnet going on? Wyatt, has it been smooth sailing? How has node onboarding gone? Anything else you have to update on that?
I think we all had a little PTSD from the first 2 years of just everything. There's definitely a lot of white knuckle moments. But no, I mean, things could not have gone smoother. And the team has been onboarding. I mean, everybody's signed up for roles. And yeah, I mean, it's just not a clusterfuck, which is, exactly what I could have hoped for. So I'm a smitten kitten. We're onboarding our next batch.
Awesome.
So I mean, we look forward to showing more demos and stuff. We're about to probably end releases on the current version of mainnet. I'm not sure if we'll 1.0 it, but we're going to start moving towards a beta version of a v.2, which I think we're going to call 1.5. I actually need to look at the versioning. Might have been looking at the wrong one, but we'll have more updates on that in the next coming months.
Awesome.
Hey Wyatt, maybe you want to talk through on my shared screen here. I have Stargazer, which is basically a monitor of our network. And maybe Wyatt, you want to walk through this. This was actually created by our community as a way to provide transparency to our node operators. Maybe you want to walk through this.
Yeah, 100%. So this is really just a little bit more involved Block Explorer. In addition to DAG or block monitoring tools, we have metadata about all the nodes, and this is getting read directly from a Grafana instance that we have as well, which we can go over. But these are just quantifiable metrics that we think make sense, and we wanted to share with the network. So. I mean, the throughput's pretty low, but the latency is incredibly low, but so is the throughput. So, but yeah, I mean, we're confirming in sub 2 seconds, at least on the block height. So, I mean, it's super fast. No transaction fees. I think a lot of people didn't know that. At least, everyone has a free transaction every 45 seconds, and so you can pay extra to prioritize if needed. And that's
where DAG comes in. The utility of DAG, paying for the increased throughput, pushing through above your free allowance.
Yeah, exactly. So the real core here is that DAG is a numeric quantity that's topologically invariant, or rather it's been normalized using a topologically invariant metric, which was metric entropy. And so by using that to host the actual interfaces and definitions of the state channel nodes themselves, and then to act as sort of how to put it, a translator between geometric spaces. If that makes any sense, because the data is just all parameterized geometrically. Absolutely.
And so this is where, and we can get into this later, but this is where your paper on blockchain cohomology happens, the establishment of the smooth transition of geometric spaces between state channels. If that is, all right.
Yeah, exactly. Awesome. Yeah, the real thing here is basically we just need to be able to translate one space to another. So talking calculus, which is how I learned all this stuff and got into, we call it a differential pullback on a differential form when we're dealing with a smooth manifold. But there is a similar definition from the language of homotopy theory and cohomological calculus, which is that one could say that the morphism or some type of action that moves to a higher order, I think, would be the dimension on the chain complex. Basically, there is no loop. If that makes any sense. So when we go from state X to X1, we preserve the, it's loop invariant and it preserves bratings. And so what that does is it makes sure that we have a view of the past that doesn't have any potential, how do I put it? There's no potential conflicts. Exactly. We form a totally smooth view of the history.
Awesome. So you can go both not only up and down within the different levels of the constellation topology as it stands now, but also from now into the past with a smooth transition as well. Is that what you're implying?
Oh yeah, exactly. So I'm referencing some footage we took a little earlier, but if we take a look at how you would define a sequential, like one state channel sequentially taking the data from a previous one, it's basically like A and then a bunch of arrows to B. What you're seeing there is that all of the concurrent operations from A then get mapped to some sort of lifted in between state and then go into B. So that just make sure that at any given state,
lifted state is what needs to be properly calculated by the Constellation network. Like that's why you built this DLT.
Yeah, it's basically just to be like a parent type in a hierarchy of all the different state channels. So like if you extend and are like an instance of our like topos DAG interface, then basically you can speak the same language, send the same data back and forth as anybody else's. Or rather, I'd say not the same data, but that the state proofs are like you can, parameterize them.
That heterogeneous data transversal, like that has some latency, I would assume. Yes. So
we
that,
go ahead.
Go ahead.
So in some cases, we need to have latency in order to allow the network to converge for consistency guarantees. And so that's what we do is we would use a monad transformer to transform one state channel into the composition of itself in another one. And so that's what that is. And so we want. Yes, depending on, it depends exactly whether that's a cell or two cell on the specific thing. But from the Constellation lens, we would be using a two cell because we use a gather under the hood for consensus. You can define your own consensus too.
The great part about what you're talking about, I'm not sure because you guys have your own ecosystem to worry about. But recently there was this like really dramatic fight about the Avalanche developers and the Polkadot developers about like, well, my platform is better than your platform, and they're looking at all these different like approaches. But one of the defining features about Polkadot is that they have a finality gadget, where you blocks are accrued over time, and then after a certain point of time, it's not a smooth transition. It's like there's one consensus algorithm and there's the finality gadget that makes it like, oh, it's final. But what you're saying is that it's a smooth transition towards finality from the deepest reaches.
Yes.
So I love that approach. Yeah. It's fantastic.
Yeah, thanks. So basically, as long as we adhere to the rule of the DAG, I guess you could call it, which is that these blocks are sheaves that form, I believe, what's called a Finto-Po set. Basically, like there's some type of a relative like reality, right? I mean, this actually just gets down to the theory of relativity, how we handle many body systems, right? So the idea here is we want to have some type of a relative Po-set topology, right? It is the correct, just generic term. And so just in general, within Constellation, as opposed to waiting for discrete steps, which would then cause an issue, in terms of the entire network being able to be elastic, scale up, scale down, handle that fluidly. What we do is we have a finality window of 10 we call snapshots, which are fully closed loops within the DAG. So starting from one block, you can path your way all the way to the next block down here and encapsulate all the other blocks in a state proof. So by forming that closed loop, for those you're thinking about like graph flows, you can think about, there's some fun stuff you can do there too. I'm not going to get into it, but yeah, the TLDR is that, and so that's when our reputation model comes in. So we're constantly gathering information from nodes that are proposing their local view of what happened in the network, and then those get proposed and can never be they can never be like undone. Otherwise, we do like shadow bans. Shadow, I mean, it's banning if it's a double spend. It's considered that if you propose invalid or incorrect data. So and then basically what happens is over time, nodes are constantly processing and receiving blocks all at different times. So this sort of convergence window slowly occurs within some sort of average time block. And in the case where there is a disagreement within the network, in this case, we actually haven't, witnessed a double spend, which is lovely, or at least it's been filtered out in the first steps. So no one has modified their node code and done that, which we will. I mean, it'll be in the DAG. You're out. But yeah, the point I'm getting at is that in the case where we actually do need to do what we call a redownload, which is where nodes change the previous hashes, and this happens all the time, just if they're missing data or something happens on a slightly different interval, then they're still able to process data. So like at no point do they stop. They just perform a concurrent process, which creates new blocks, and they're still streaming blocks at any given time. So all we need to do is just
back together, recoheres the DAG.
Correct. Yeah, exactly. It's like a recoherence mechanism. And all we need to do is just make sure that the recoherence mechanism is shorter in terms of like latency than, I don't know exactly what the term would be, but a comparable thing in terms of back pressure that we have for creating blocks, which we do. And that's typically where, and we haven't released this yet, we're waiting until after the stage handles just to, make a more succinct thing. And also we don't want to give away all the, the good juice right at the front.
Don't give away your secret sauce, please. Keep going.
Well, it's just secret metrics. It's, we're really cool because, it's super fast. Basically, yeah, like under the hood, when we actually want to increase, basically if the network starts getting slow and backlogged, then what we want to do is, I'm trying to think, I think we want to add nodes in that case and then increase the actual finality window to try and meet that, because we always want to try and make sure that's as small as possible. Otherwise, we're sending too much data around the network, which ends up making it slow again. So there's kind of this window, which is cool, and we're going to have a fun hyperparameter search where you'll see that in a graph, and it forms hopefully like a relatively linear curve, which is what we've seen. So it's horizontal, which is dope.
One thing I have to mention, this reminds me of, is the determining of whether data is valid or not has because I've been learning about like how law applies to different technologies, and to me like there's different paradigms of law. Like for example, the EU works on like what was it? Not like so America's case law. You set a precedent, and then that precedent you work from there. And that precedent-based law administration seems the approach Constellation is taking. Like the first thing you put out there, that's you put that out there, and if you ever go back on that, that's when the repercussions happen. Is that
right?
As far as okay, cool. That's good.
Oh yeah. So from the perspective of what you I think mentioned before, which was some type of like a what was it called? Like a law as a process, or what was that phrase? Essentially, seemed like a. Go ahead.
Like it's a means of administering law. I mean, that's just like a framework of law.
Oh yeah, what was the phrase you mentioned? Like some type of a protocol, like enforced.
Oh, regulatory compliance automata.
Oh yeah, regulatory automata. I really like that phrase. I'm going to start using that.
It's cool.
It's wonderful. Well, basically, it just sort of allows us to define regulatory enforcement as the convergence of smaller decentralized automata. So instead of a centralized source, you would then actually have like a Constellation state channel act as a DAO, which it always is at any given point. There's no centralized aspect of it whatsoever, no leader, and they come to convergence on state. You could basically have that come to convergence on the state of some type of a data type. And as opposed to like in Ethereum, oh, we only have 4 data types which can go inside of the DAO. Instead of that, you define your own data type, and that's how you validate it. And then also how you validate it with relatively to other people. And so what's really cool here is that by looking at how difficult it is to retroactively forge these types of graph proofs, you can calculate how hard, expensive, and how probabilistically like difficult it would be for someone to forge something in a time window, which gives you guarantees about accuracy.
I think we lost a lot of people, but I absolutely adored that explanation. Thank you, Wyatt. Benjamin, Luke, please bring us back. We went into the realm of magical candies and lollipops for too long.
I'll bring it back to something really simple, and I think that Wyatt can really bring this into something that we're doing is focusing on evolving past smart contracts. So maybe to take a step back is to have Wyatt explain the value of a state channel ecosystem like we're building and why smart contracts will be obsolete.
Yeah, I think I can like describe that a little more succinctly, what I just said, which is that from like a state channel or a smart contract perspective, you're trying to create an external oracle to pump data in to work within a small sandbox of certain data types that are verifiable. For Constellation, you can define any data type that you want that's verifiable because you defined the validation logic. Let's say if like we're sending a ledger balance in the DAG case, it's whether or not the ledger balance is within the range of the balance that you have. So just as an example, and sort of what makes this like different is that we take a relative approach to verifying every data type such that individuals can create an objective reality out of state channels. So like instead of I create a smart contract and I create like this, you know, centralized relay Oracle node and this centralized Oracle node, you can define state channel nodes as, well, basically an Oracle is equal to like a swarm of state channel nodes. So it's their convergent behavior. And that's why I really like that phrase, because you called it like an agent or an actor, and that's how we describe these types of, you know, conversion processes. You know, when you're looking at like differential flows in math for like, you know, statistical mechanics, things like that. You can also model many body systems, like how the internet works with the Erlang model. So in the same sort of sense, we've, you know, taken it locally by using a monadic execution context instead of an actor, and that's how we like took it to the next level to HTTP as of like instead of on top of the ISP.
So it's like a herd of geese is a singular thing, but it's not just one big goose. You have a lot of different geese that make it up, and that then go from one place to another. And so this swarming mechanism is definitely, it seems like the most equitable means of providing Oracle data to networks.
Yes.
And Overledger is actually going to be able to help you monetize that via the multi-chain oracles. So you know, Constellation and the variety of different verticals of data that it can represent and pre-process and do whatever to it, it can actually sell that for different units of account via interchange automatically via the switch station that Benjamin described Overledger as. Like that seems like a very natural fit with one another. Like this, instead of the what was it? Not instead, but like as an accoutrement to the Chainlink style of approach, which is, you know, very federated and designated top down of like, oh, you're a Chainlink node. So, and you can provide Oracle because you're a Chainlink node. but yeah. So that's amazing. Luke, do you have any thoughts? Where are you at?
Yeah, look, no, that was very interesting. As you mentioned, I mean, a lot of us are probably a little bit lost in the source there, but it's always good watching you guys nerd out. It's awesome. I had a question for Ben. As we started off, we talked about the fact that Quant is building a way for enterprises and developers to kind of have like a sandbox environment, or where like the network, you know, a seamless communication between everything. What sort of value do you see Constellation bringing into that network, where existing clients, enterprises, or developers could use Constellation to better their current services? We know that Quant is big in the financial industry. Is there any way that fintech data streams or something like that could be monetized via Constellation through Overledger?
Yeah, absolutely. I know Wyatt has some thoughts on this, but one of the interesting things that Constellation's doing is we're appending more data to a transaction. So when you think of financial data, you think about where did that come from? What was the source of it? What was the history of the financial transaction? And really appending the payload with complex data types will serve a ton more value to financial institutions around, not to mention who had access to that last transaction. Where did it come from? What was that? Way beyond just the timestamp. There's so much value that will come in that room. The other major value that DLT, and this is, Wyatt's whole vision was to make this integratable with existing data management stacks, modifying the Spark plugin. So there's a lot of what we're doing that is really meant to, going back to what we were talking about earlier, make it easy to procure blockchain technology. How do you sell it? How does one integrate it? And then is the technology scalable to mirror what is expected in terms of data transfer in a centralized capacity? Mm-hmm. So a lot of this is our value is really making the a blockchain decentralized network procurable, scalable, and making your data more secure at scale.
With the Constellation seal of approval.
Right, and like the powered by Intel sign is what we say.
Yeah, the secured by Constellation.
So one of the fun things that comes into mind when we think about Quant is working with Quant to establish a new line of business solely around data management and the movement of data and the transportation of data. And I think Quant's focus on that application switch and application layer and making it easy for enterprises to plug in will be super compatible to what we're building on the deep infrastructure layer.
Well, and it sounds like a natural extension of what the FDA is trying to do with the DSCSA, the recent initiative for digital securing of pharmaceutical lines. Constellation's utility, and again, the Constellation seal of approval is a natural solution for all these trials that they're trying to do right now. Like, there's so many different DLT projects that people are trying to throw it on. And of course, they're doing it from an approach that is not naturally scalable as Constellation is. It's very synthetic, which, of course, because Constellation is a technology, it's also synthetic. But Constellation is naturally synthetic, or synthetically natural, whatever way you want to put it. So that seems like a wonderful opportunity. Have you guys explored securing pharmaceutical lines? Is that a
so I think you highlight something that is really fascinating, is who perceives the value of moving a digital asset to the level of the blockchain market capitalization. The size of blockchain as an industry doesn't equate to the value that digitally tracking an asset from A to B to C. And we have talked with numerous partners that did a lot of those pilots, including the federal government, that have explored a lot of this. And they're like, we don't see the value in just cryptographically securing an asset for supply chain management. There's value, it's interesting, but it's not going to move people. Now, when you're talking about information assurance, that's a completely different category in its own.
Yeah.
So one of the interesting things that I think we can do with Quant is really tell that story around information assurance and making it friendly for enterprises to plug in not just blockchain and other DLTs, but around a blockchain that matters. working with your data and being able to plug into your existing initiatives and know that you have more information assurance in its lifetime. Like,
yeah. And go ahead, Wyatt. Do you have anything to add to that?
Yeah, just really quickly, I kind of just want to leave you with a shift in perspective. Originally, this was framed at how can we create some type of a supply chain management for the creation and tracking of some type of pharmaceutical IP, whether it be the process or the actual formula. But what actually went into the process of creating that IP? Everything started from some type of a data set that they got their hands on, that some type of a bioinformatician wrote an algorithm for, that then got some chemical engineer to then create some type of spectrum for, which then created an entire data pipeline, one could say, that ended up creating that one unit of value. How does one actually keep track of what went into your products, either even from a conceptual lens? And if we were to able to democratize this data pipeline from each different lens of the industry, would a greater diversity create more competition and thus greater consumer choice in terms of the medical field? Who's to say? I don't know, maybe.
We all need it. I mean, pharmaceuticals are very expensive.
I mean, it's almost like, yeah, go ahead, yeah.
I just wanted to say one thing that you're basically describing, like automatic mimetic archaeology.
Mm-hmm. Yeah, pretty much. Pretty much. I mean, I'm not going to go into the meme stuff, but like that's kind of how the reputation model works. We actually, we just look for disparities. We look for incongruencies within behavior in order to figure out some type of a narrative that we can form and thus act based upon the data that's available.
For sure, man. I mean, that's all you can ask for.
Just before we go any further, Ben, I know you've got to run off for another call. I just wanted to say thank you for popping by. I know you're super busy. Ghost and I are very appreciative of the fact that you stopped by to talk to us. Thank you. Yes, thank you.
Guys, this is a lot of fun. I can't thank you enough for the time. And Wyatt, it's always fun to rap with you on this stuff. So
yeah,
we always
likewise.
learn something new about ourselves.
I would actually love to hear Wyatt wax lyrical about a concept I've been liking to call the digital new world. Which is like the colonization of existing infrastructure into this cryptographically secured digital realm, where digital twins mirror real life and real life activity. Has Constellation been approached, or have you guys explored like DAOs and what do you see in general about like this wave of, people call it digital transformation. The meme's been overused, but it's still true. Like software eating the world. Like, how does Constellation play a role in that?
If I were to sort of, maybe chop that into some sushi bits, some bite-sized pieces here, I'm going to craft a narrative. So like the idea here is how do we maybe not necessarily colonize, but make use of a new type of land grab that exists on consumer hardware that, just isn't getting used. So let me just imagine, like for Constellation's perspective, like you can spin up, like a current mainnet node on a MacBook Pro. And so like in general, once we totally open this thing up the next 6 months, there's going to be a lot of consumer hardware sharing their space and their computational availability, creating a marketplace for untapped resources. So obviously, there's a lot of economic perspectives here. Like you're creating, there was basically like an untapped resource that's now going to flood into the network. How's this going to change, cloud computing? So there's that. Kind of a perspective. But I think the real shift in perspective here is individuals creating autonomous processes and coding what I would call like convergent or generative programs. I think the correct phrase would be generative, like a generative system. This being in the same sense like a functorial operator that can, can imbue like wave dynamics, if you will, like they are governed by differential equations. So without getting into the specifics,
well, we're seeing that right now in DeFi. Like that's the bonding curves that govern all these economic tools that are taking off right now are exactly what you say. they're governed by wave functions.
Yeah, I mean, to some degree, a protocol, at least if you formulate it in terms of like a group action, or like in terms of that blockchain cohomology paper, like it is a differentiable manifold, and sort of like the core crux, which, I'll leave a little Easter egg. Like basically, when I started this, I was like, how can I create a monadic equivalent of a Fourier transformation, which is like infinitely differentiable and or parameterizable and or like push or pull back forward or backable. And so the idea here was to create something akin to a day convolution. And we've actually done something, we've done that and a little bit more. It's, I want to say, well, I'm not going to get into it, but basically like we've created an actual smooth space upon which data can translate. And the real core here is learning how can we use like the mathematics of, category theory and, monoidal categories in order to create emergent phenomenon that is like one in itself, its own new realm of mathematics I could ramble on about for a while that I was into in school, but also that really is the solution to a DAO, a decentralized autonomous object. It can't necessarily exist within a confined space in terms of like data and what it can operate on. Otherwise, like there are just going to be limitations to, its accuracy and what its autonomy will be. I mean, you need to create like a free category, albeit enriched, so like preserve some type of post-set topology, like it needs to be free in order to infinitely grow. And also the freer and larger it becomes, the more populous these sort of emergent steady state solutions that can handle like a double spend or a network fork or something like that can actually occur.
Awesome. Perfect. Luke, maybe we can ask him about smart cities and how composable those will be within his vision. But I don't know. I think that was a pretty awesome way to end it on.
Sure. I was also thinking maybe you could talk, maybe just like spitball the idea that we had a few months back where, I don't know if you know, but the team at Quant are building interchange, which is like a universal settlement engine, so you can settle in any currency using like Swift, CBDCs, digital currencies, etc. It would be very cool, and using treaty contracts, which is like multi-chain smart contracts to sign and verify them. It would be very cool if Constellation could extract that transaction as a price feed, almost. You know how Chainlink uses their technology to authenticate price feeds. If you're having live transactions authenticated on the blockchain network and then Constellation kind of extracts that data to make it usable, I think that would be a pretty cool use case. I don't know if you want to talk about that more, Ghost, or what do you think?
I mean, go for it.
I mean, it's a prime example and use case. I mean, basically, we would just add a small connector piece on top of that lifted, like let's say a Quant implementation into, the DAG space, and then sent it, back to you guys and sort of close the loop. But I don't want to spoil another Easter egg, but basically, we've got a lot of work right now. One, in terms of how are we going to handle market dynamics for ICOs on Constellation, and the funding of projects for individuals trying to, sort of create like an escrow in a space. So we have some stuff we're going to be sharing on that, but also from the perspective of, how do we actually want to handle validator rewards? As of right now, it is currently in the works that we're creating a reactive mechanism that's going to look at price dynamics in order to dampen payouts to node operators in times of thin liquidity in certain ranges. So we're going to make sure that the largest creation of DAG is mitigated to some degree. So the goal is to create something similar to a stable coin that is exponential. So instead of, basically if you hold a fuck ton, it might have a bit more of a, effect, but if you're a smaller, casual individual or user or developer, you just want to make sure that wild price fluctuations don't affect your ability to utilize DAG as your, consensus as a service tool.
Awesome. So a stable coin that isn't pegged to the dollar, that's pretty innovative.
No. Yeah, it's pegged to the ability for the market to, eat up, someone who's receiving validator rewards at a certain time, and also that's going to be exponentially dampened as the value of DAG goes up. And the only constants that we're actually using are the cost to host a node.
Gotcha.
So this is essentially just like arbitraging, this sort of decentralized AWS type effect, which will happen for state channels. I mean, you'll be able to basically just farm. Like, I wouldn't call it mining; it's like farming, because instead of, you're basically mining ERC20s, but because this is such a real dynamic thing, if you have server space, you can switch it over to carrot chain versus corn chain or broccoli chain, depending. Yeah, and you can arbitrage based for what's hot in demand based upon the resources you have. So, I mean, it really is kind of in a weird way. I mean, I'm seeing this as kind of like a this is all the pieces. You buy like a disassembled piece of furniture from IKEA. This is all the thing that you need to create a data exchange, but also a hardware rental exchange. Cloud computing service at the same time.
Well, that's actually a huge problem I've seen in so many different blockchain projects. Is that they don't know how to price their utilities. They either give a base license fee, or they have some arbitrary rating mechanism that isn't really accurate to the true work being done there. But by you commodifying your utility and making that commodification as accurate as possible, because it is essential for the ecosystem growth, that's the basis of that digital new world I was talking about. I foresee literally so many different companies like Walmart, like tokenizing the revenue flows of the different products they're sending back and forth, and using that feature that you have for Constellation as a service for them. That's a whole new pillar of asset right there. You have debt, you have stock, and you have this tokenized revenue flow. And if you can embody that, then they can be their own bank, because that's their own stable coin.
Exactly. You've essentially tokenized. Yeah, you've created a commodity out of throughput or out of data availability. And actually, if I want to do something kind of funny, can I share my screen again for 10 more seconds?
Oh, dude, do it.
All right. So I'm showing you guys how I came up with the base layer currency units and dimensions, and it's kind of funny. It's kind of funny that we have this really famous thing called Bitcoin, when I'm pretty sure I was the first person to actually define Bitcoins. Take a look right here. So right here, we actually have we've defined a volume, a geometric volume that represents some type of utility, which we know has a one-to-one corresponding or correspondence to our real memory or disk space that we have to perform something. And you'll see right here that the actual units that come out, I'm trying to think, it's on this other page, are bits per second. What the hell is that? Bit SOE per second. So it's the Shannon entropy there. And this is all relative to all the other state channels. I don't know where there was a really awesome unit I had that was bits per second or something. But anyway, it's on there. Maybe this is old.
We actually had, I was reading this paper before, and I was telling you about this page. I think this is an older edition of the paper. You might need to get
There's this guy named, I'm not even going to bring it up. We had this, Anyway, let me see, what was that, May 22nd? Well, anyway, basic different, I think that's it. But basically, the whole idea here was that we just wanted to create, that space that was bits per second, which is just throughput. It's just you're solving a flow problem.
Gotcha.
What the hell is that? Yeah, well,
it might not be in GitHub. It might be, where's the other place you're hosting your papers?
Archive, but it would be on the archive, or it would be on here because I linked it there. But yeah, it's all good.
Yeah, no worries.
Yeah.
We're ending that line of thought on a meh. But the fact that you can commodify bits of entropy is it's so good. It's so good. That's exactly what we need.
Yeah, I mean, that's really it, man. I mean, it's, if you wanted to treat something like a commodity, we did this one a long time ago when people were first creating open markets. Is it really just boiled down to a physics problem? How do you create like a representation of some type of utility? And if there's some transitivity between it, then you need to encapsulate that in order to have a closed system where you can have some type of a quantifiable unit of value. And typically we try to find those unifiable units like in the commodities markets, but there's really no fidelity to the data that we get on those. So there's, we could talk for hours about issues on, trading on access to data and like, is the market really free if people have access to truth and are getting disinformation on the commercial? But I don't know. I don't need to wax too philosophical.
No worries.
But yeah.
Thank you so much for your time.
Cool.
Thank you.
Oh, thank you guys.
Thanks heaps, Wyatt, man.
Yeah.
It was awesome.
Yeah, right on. I'll talk to you guys soon, all right?
All right, take it easy, man.
Peace.
Cool.
Catch you later.
All right, later.
Bye, man.
Peace, guys.
Well, thank you everyone for tuning in today with that little interview there with Ben and Wyatt. Again, thank you very much to both communities and Benjamin Wyatt. Obviously, thank you Ghost as well for tuning in. It was a lot of fun. We've got a bit of practical use cases in there as well as Ghost and Wyatt geeking out a bit on some of the more intricate details, which is awesome to see. Thank you for watching. I hope you guys tune in for our next episode.
Absolutely. Next time, I promise not to go quite so ham on the technical specifications. But yeah, you all stay quampy. We'll see you next time.
Yeah, appreciate it, guys. Peace out and take care. Bye.